Imagine fueling your car, plane, or boat with something that looks, smells, and performs exactly like regular gasoline, diesel, or kerosene. You fill up the tank, turn the key, and go. The engine hums, the aircraft lifts off, the ship sets sail. But instead of coming from oil drilled in the deserts of the Middle East or the bottom of the ocean, the fuel was made in an entirely different way, synthetically, almost from air, using nothing more than electricity, water, and carbon dioxide. It might sound like a scam or just another science project that'll never leave the lab, but it's real. This is e-fuel, synthetic fuel that's already being produced in pilot facilities across Europe, South America, and the United States. And in the coming years, it could completely change how we drive, fly, and ship goods. How is something like this even possible? How can you make oil without oil? The key lies in combining two basic, affordable substances, hydrogen and carbon dioxide. Hydrogen is produced by splitting water using electricity, ideally from wind or solar, making the process fully green. CO2 can be captured either from industrial smokestacks or even directly from the atmosphere using special filters, a method known as direct air capture, DAC. Once captured, both substances are fed into a large industrial reactor, where under high temperatures and pressure, they're fused together in a process called Fischer-Tropsch synthesis. This technique has been around for almost 100 years. It was originally used by Nazi Germany to produce fuel from coal. The result is a mixture of hydrocarbons, the exact same molecules found in gasoline, diesel, or jet fuel. Here's how the full process works. First, renewable electricity is used to electrolyze water, producing clean hydrogen. That hydrogen is then mixed with CO2. Inside the reactor, catalysts help form long hydrocarbon chains. These are then refined into e-gasoline, e-diesel, or e-kerosene, depending on the intended use. In some systems, the process first produces methanol, which is then converted into liquid fuels. The big advantage? All of these fuels are chemically identical to their fossil-based counterparts, meaning they can be used in existing vehicles, planes, ships, and engines without any modifications or retrofitting. Why is this such a big deal? Because aviation, shipping, heavy-duty trucks, and older internal combustion cars will still rely on liquid fuels for decades. Electric batteries are excellent for city driving, but a commercial aircraft, cargo ship, or long-haul truck is not going fully electric anytime soon. E-fuels offer a solution. They allow us to decarbonize these hard-to-electrify sectors while also using existing infrastructure, gas stations, pipelines, storage tanks, even the vehicles themselves. The benefit is obvious. No need for a full revolution. No mass scrapping of cars. No 100 million in new tech. You just start fueling with something new. The key principle behind e-fuels is carbon neutrality. If you capture CO2 from the atmosphere to make the fuel, and then release that same CO2 when you burn it, the cycle is closed. The net result is zero carbon emissions. And if you use renewable electricity in production, the process is genuinely clean. That's why e-fuels are gaining serious interest, especially in sectors where batteries are still impractical. Aviation, e-kerosene, used by companies like Infinium, Airbus, Lufthansa, maritime shipping, e-diesel and e-methanol, used by Maersk. Cars and motorcycles, Porsche, Ferrari, BMW, all testing e-gasoline, military and commercial trucks. In late 2022, Porsche and Siemens Energy launched the first industrial-scale e-fuel facility in Chile. Why Chile? Because near the Strait of Magellan, wind blows almost constantly, meaning wind power is virtually free. That's where the first batches of e-gasoline are being produced and already tested in high-performance cars and prototype aircraft. Similar projects are under development in Norway, Germany, the United States, Infinium in Texas, and Australia. Luxury car makers and airlines are leading the charge. Lufthansa, for example, plans to blend e-kerosene into fuel for transatlantic flights. So what's the catch? Right now, cost. Producing e-fuels is still many times more expensive than refining fossil oil. A single liter of e-gasoline today costs between $10 and $20, depending on electricity prices and CO2 sourcing. But costs are dropping fast. By 2030, a liter of e-fuel could cost as little as $2,000 to $3,000 in places like Germany. The major advantage, no need to modify engines or fueling systems. You can use e-fuel in any regular combustion engine right now. It's energy intensive too. From 100 kilowatt hours of renewable electricity, you get only about 40 to 50 kilowatt hours stored in fuel. Yes, less efficient than batteries, but But compared to biofuels, it's much cleaner. No farmland, no fertilizers, no deforestation. Another benefit is stability and storage. E-fuels can be stored for years, transported by ship or pipeline, and used exactly like today's gasoline or diesel, making them an ideal energy carrier. What are the downsides? First, the price. Still high, though decreasing. Second, clean electricity is essential. If hydrogen is made using coal-fired power, the environmental benefits vanish. Third, the scale. To replace global gasoline demand, we'd need to massively expand renewable capacity and build thousands of electrolyzers and DAC units. And finally, efficiency. While electric vehicles convert 60–70% of grid electricity into motion, e-fuels only utilize about 30–40%. But what they lack in efficiency, they make up for in versatility. Immediate compatibility with vehicles, planes, and ships without requiring new infrastructure. That's why experts believe e-fuels won't compete with EVs in city traffic or short trips. Instead, they'll play a vital role in aviation, long-haul transport, and global shipping, where internal combustion is still the only realistic option. The European Union has approved e-fuels as an exemption from its post-2035 combustion engine ban. Several countries are already drafting legislation to support their mass deployment. Just a few years ago, e-fuels were a lab experiment. Today, production has already reached thousands of liters per day. Cars are racing on them, planes are flying on them, and full-scale commercial rollout is getting closer. If progress continues, we could soon be choosing at the pump between gasoline, diesel, e-fuel, or electric charging. E-fuels might just be the lifeline for combustion engines, saving existing vehicles from extinction under strict environmental regulations. They also serve as a powerful energy storage medium, letting us store excess wind or solar energy and use it later, whether in a month or a year. In a world fighting climate change, oil dependency, and emissions, synthetic gasoline, diesel, and kerosene might be the unexpected ace up our sleeve. So the next time someone says the future is electric, remember, the tech for carbon-neutral liquid fuels already exists, and the first drops of the new era are already in the tank. Subscribe us for next videos.